Hi everyone. In this video lecturing we can discuss about the last portion of our module 6, that is microprogrammed control unit. Already we had discussed about the hardwired control unit and microprogrammed control unit architecture, in which hardwired control is actually contains a large number of wired connections, so it is very difficult to design. Actually, the complexity of this hardwired control is very high. It is difficult to design as well as it is difficult to change the design. So we can use another implementation techniques for control logic unit design, that is a microprogrammed control unit. So every instruction in a processor is implemented by a sequences of one or more sets of micro operations. So all the micro operation is associated with a specific set of control lines, and since the number of instruction and the control line is often hundreds, so the complexity of hardwired control unit is also very high. To reduce this complexity, we can use a microprogram control techniques, in which large number of micro instructions are used, and the sequences of micro instructions are known as microprogram. Actually, these microprograms are stored in a memory that is known as a control memory. So the control signals to be activated at any time is specified by a micro instruction which is fetched from a control memory, and the sequences of one or more micro operations designed to control the specific operations such as addition, multiplication is called a microprogram, and the microprograms for all instructions are stored in the control memory. And this is the architecture of microprogrammed control unit. So the main components of this architecture is a sequencer, that is otherwise known as a microprogram sequencer. Second one is a control address register, and the third one control memory. These are the three main components of a microprogrammed control unit. Along with these three components, we have a micro instruction register, decoder, instruction register, etc. Address where these micro instructions are stored in control memory is generated by a microprogram sequencer or a microprogram controller. So what is the function of a sequencer or a microprogram sequencer or a microprogram controller? They are used to generate starting and branch address of a micro instruction. So it's an address generator. Already we had discussed the architecture of microprogrammed control unit. In that architecture, we can see along with control memory and control register, there is a control address generator, okay, or the micro instruction address generator. That micro instruction address generator is known as a microprogram sequencer. So this microprogram sequencer generates the address for micro instruction according to the instructions stored in the IR. What is IR? IR is a instruction register. And what is the use of instruction register? It's a register that they are used for storing instruction. So based on the instructions stored in the instruction register, this microprogram sequencer, it generates the address for micro instruction. Okay, so the main component of the microprogrammed control unit is a control memory, control address register, and a sequencer, microprogram sequencer, along with micro instruction register, decoder, as well as instruction register is there. And why we are using instruction register? For storing all the instructions. And why we are using microprogram sequencer? We can generate the address for micro instruction according to the instructions stored in the instruction register. Okay, and why we are using control address register and control memory? Actually, output of control memory is a micro instruction or a sequences of micro instruction. Okay, and these generated micro instructions are stored in a particular register. They are known as micro instruction register. Okay, and this micro instruction register, if we want to decode that instruction, it's a if we are execute an instruction and the previous step is a decoding state. For that, for decoding a micro instruction, we are using a decoder. So for generating address for a particular micro instruction, we can use an external inputs and condition codes to the sequencer, that is a microprogram sequencer. Okay, so this is all about microprogrammed control unit. So main components: control memory, control address register, micro instruction register, and microprogram sequencer. And why we are using microprogram sequencer? For generating the address of micro instruction according to the instruction stored in the instruction register. Next, we can see what are the advantages of a microprogrammed control. It simplifies the design of a control unit. So the main advantage of microprogrammed control over hardwired control is in the design phase. That means it simplifies the design of a control unit. That is, it both cheaper and less error prone implement. So cost wise, they are less cheaper than that of hardwired control, and also it is less error prone implement. Okay, and the control functions are implemented in software rather than a hardware. The design process is orderly and it is systematic, and it's more flexible and can be changed to accommodate a new system specifications or to correct the design errors quickly and cheaply. And the complex functions like floating point arithmetic can be realized efficiently by using this microprogrammed control. So what are the advantages of a microprogrammed control? They are cheaper, less error prone, and simplicity in design of control unit, and the control functions are used or implemented in a software rather than a hardware, and the design process is an orderly one or it's a systematic one, and it is more flexible, and we can implement more complex functions like floating point arithmetic, etc. So these are the advantages of a microprogrammed control. And the main disadvantages of a microprogrammed control unit is somewhat slower than that of hardwired control, because the time is required to access the micro instructions from control memory. Okay, so the main disadvantage of a microprogrammed control over hardwired control is its time, because it's slower than that of hardwired control, because the time required to access the micro instruction from a control memory is more than that in hardwired control. And the second disadvantage, and the flexibility is achieved at some extra hardware cost due to the control memory and its access circuitry. So actually one of the main advantage is flexibility, but hardware cost is somewhat extra, so it's also a disadvantage compared to hardwired control. So we have a control unit, and how to design a control unit by using main two implementation method. One is a hardwired control, which uses large number of wired connection and hardware, and the second method is actually a microprogrammed control unit. And the main advantage, simplicity, flexibility. It uses software rather than hardware, and the design process is orderly and systematic, and they are more flexible. It can be changed to accommodate a new system specifications, and it can be used for implementing complex functions like floating point arithmetic. And the main disadvantage of microprogrammed control over hardwired control is it is somewhat slower than that of hardwired control. So these are all about the microprogrammed control unit. Next, short notes on microprogram sequencer. And what is a microprogram sequencer? Actually, a microprogram sequencer is one of the components in a microprogrammed control unit. And why we are using a microprogram sequencer? We are using a microprogram sequencer for address generating purpose. So the microprogram sequencer is a control unit which do the tasks of microprogram sequencing. It sequences the microprogram. What do you mean by a sequencing of a microprogram? That means generates the addresses of microprogram. What is actually a microprogram? Microprogram is a set of instructions. That means sequencer generates the address of the microprogram instruction or micro instruction. And there are two important factors must be considered while designing a microprogram sequencer. One is size of the instruction, and next is the address generation time. So the size of the micro instruction should be minimum, so that the size of the control memory required to store the micro instruction is also less, and this reduces the cost of the control memory. With less address generation time, the micro instruction can be executed in less time, resulting better throughput. So these are all about microprogram sequencer. It is the main component of a microprogrammed control unit which are used for generating the addresses of a microprogram or the addresses of a micro instruction. And the two important factors that must be considered while designing the microprogram sequencer is the size of the instruction, and it should be minimum. And the second one is address generation time. So with less address generation time, the micro instruction can be executed in less time, resulting in better throughput. Next one, microprogrammed CPU organization. That is a central processing unit. How we can organize a CPU? By using a microprogrammed organization. This is the architecture of a microprogrammed CPU organization. So a digital computer, it consists of a central processing unit, a memory unit, and input-output devices. Okay. So the main component of a digital computer means it's CPU, central processing unit. Along with central processing unit, the other components are memory unit and input-output devices. So CPU can be classified into two distinct but interactive functional sections. One section is the processing section and the other section is the control section. Okay, CPU means it's a central processing unit. So the CPU contains registers, a processing unit as well as a control unit. So main two sections are there in CPU. What are they? They are, one is processing section and other one is controlling section. Why we are using two sections for a CPU? Processing section which process all the micro operations, and what is the use of this control section? Control section which controls all the micro operations that is processed in the processing section. So the CPU has two distinct interactive sessions or sections. One is processing section and the other one is control section. So this is the block diagram of a microprogrammed CPU. It consists of a memory unit and two processor unit are the microprogram sequencer, a control memory and few other digital functions are there. Okay. In this figure you can see one memory unit is there, one data processor, one address processor. So there are two processor unit. Okay, data processor and address processor, along with a microprogram sequencer and a control memory, and few other digital functions are there. Okay. There are two multiplexers are there, one code transformation PLA component is there, and other pipeline register is there. These are all the part of this microprogrammed computer or CPU organization. So what is the use of this memory unit? It stores the instructions and data supplied by the user through an input device. Okay. The same feature, that is memory unit stores the instruction and data supplied by the user through an input device. And there are two processor units are there in this organization. Which are they? One is a data processor and other one is an address processor. Why we are using data processor and address processor? data processor which manipulates data only, and the address processor which manipulates the address information received from the memory. Okay, an instruction extracted from the memory during fetch cycle goes into the instruction register. So this address processor which contains three main registers are there. Which are they? One is an instruction register, other one is a memory address register, and third one a program counter. Okay, so we are discussing about microprogrammed CPU organization or computer organization, right? We have main components: one memory unit, two processor unit. Memory unit which stores the data and instruction, and why we are using data processor for processing or manipulating the data, and why we are using the address processor. We are using address processor for manipulating or processing address information. Okay, and this address processor which contains three main registers. One is instruction register, other one is memory address register, and the third one is program counter. Why we are using instruction register, or what is the use of instruction register? Which stores the instruction that is extracted from the memory. Okay, address processor which generates address and they are given to the memory unit for fetching the instruction or data from the memory unit. And if you are fetching the instruction, it is fetched into instruction register. Clear? And this microprogram control unit part consists of a sequence of microcontrol memory, multiplexer, and pipeline register, and a microprogram sequencer. Okay, so this microprogrammed CPU organization or computer organization which consists of one memory unit, two processor unit, already discussed. One is address processor and data processor, and the other one, it's a microprogrammed control unit. Okay, and the control unit which consists of a control memory, microprogram sequencer, multiplexers are there, and pipeline registers are there. And why we are using control memory? For storing micro instruction. For storing instruction we are using instruction register. For storing micro instructions we are using control memory, a multiplexer, and a pipeline register. And what is the use of multiplexer? It selects one of many status and apply to the input of sequencer. Okay, and the pipeline register is not always necessary because the output from the control memory can go directly to the control input of various units in the CPU. However, a pipeline register speeded up the control operations. So in the control unit part, that is a microprogrammed control unit part, there is a control memory which is used for storing micro instruction, and the other one is a microprogram sequencer. What is the use of microprogram sequencer? Which generates the address of a microprogram, a micro instruction or a microprogram. Okay, and sometimes this pipeline register is not present in some of the architecture, but if we are using the pipeline register, it is speeded up the control operation. Okay. So these are the explanation. And the pipeline register which contains number of fields. First field, that is an I field, which consists of 3 bits and supplies the input information for the sequencer. I field which is used for giving input information for the microprogram sequencer. It's actually a 3-bit in nature. And the second one, SL field, it selects status bits for the multiplexer. Status select field is SL field. And the third one, branch field, is the address field of micro instruction and supplies the branch address to the sequencer. These three fields of micro operation provide the information to the sequencer, generate next address, and the control memory reads the next micro instruction are being executed in the other unit of CPU. So first three field in a pipeline register: I field, SL field and branch field. I field, which gives input to the sequencer. SL field, it is a select status bits for the multiplexer, and branch field, which supplies the branch address to the sequencer. So these three fields which are used for generating next address by using a sequencer. And the other three field in the micro instructions are for controlling micro operations in the processor and memory units. So one is MC, that is memory control. This field controls the address processor and the read and write operations of the memory unit. And the second one is the processor field, which controls the operations in the data processor unit. And the last field, that is data field DF, it's used to introduce the constant into the processor. So the pipeline register, which contains 6 fields. One is I field, input to the sequencer. SL field, it's a selection field, select status bits to the multiplexer. And branch field, which gives branch address to the sequencer for generating branch address. And the other three fields which are used for processor and memory units: one is memory control unit, processor field; second one is processor field, PS, and the third one is data field, DF, which is used to introduce the constant into the processor. So these are all about microprogrammed CPU instruction. So in this video we had discussed about what is a microprogrammed control unit, what is the architecture, and why we are using a microprogrammed sequencer. And the last portion is if you are implementing a microprogrammed control unit in a CPU or in a computer, what is the architecture? That is microprogrammed CPU organization or microprogrammed computer organization. Thank you.